So what I will do, I try to, you have in front of you the P90s of this exercise. So what we'll do now, I'll show you how I did it, slowly. I had much more time than you, so that's why it looks a little bit better than yours. And I did it in Visio, much better than you. But that doesn't change the engineering or thought process what you guys said. So we start with, as we say always, our onion model always start with the reactor, the reaction system. So carbon monoxide, hydrogen. Sorry about it, it's not very visible. Right. So first thing, we had a look on the operating conditions. That means we have to bring our reactants to 50 bar. So a few minutes ago I said we can use one compressor, but here you see even I had two compressors. So you compress your reactants to operating pressure, go to the reactor, the reaction. So at this point, I already thought about let's say the heat integration. Looking at the reaction, it's exothermic, so a lot of energy will be released at appropriate temperature. We extract energy via steam production. So already steam is generated somewhere here and it's exported. So suddenly we had two reactants in one product, but now we have a second product as well. Right? I don't know if it's properly visible here, but yes, products are formed, right? And then we separate it, then you have the product, right? And unreacted reactants will be recycled back. So a compressor is missing, this stream should have been here. Right? So please raise your hand. I'm finding mistakes in my drawings myself, but you are free to do so as well. One thing we didn't see in any of the group is, so the operating conditions you mentioned were 50 bar and 300 degree. That means we also have to somehow bring the reactants to 300 degree, right? Before going into the reactor, right? So what I thought about is your products are coming at, let's say, 300 degree. Right? What we can do, we can extract heat from the reactants, thereby heating up extract heat from the product, right? Thereby heating up the reactant and then go into the reactor. So instead of going directly into the reactor, we go to a heat exchanger where heat is supplied by the product. So it's kind of heat integration. So you have a hot stream here at 300, 320. We have to cool it to 30 to condense our methanol. And then you have one reactant or two reactant streams which we need to heat up from 30 to 300. So one cold stream, one hot stream. Remember this TH diagram, TQ diagram. Based on this, we can use this fluid effluent exchanger and recover energy, right? So we'll recover energy up to maybe, if this stream is at 30 degree, this product stream can be maximum at 50 degree, 60 degree based on delta T. We always talk about the difference, volume difference. But if this stream is coming at 30 degree at cold end, the product stream can be at 60 degree, but since we have to cool it to 30, final cooling will be. So this is the U part, the utility. So H, heat integration we did, steam generation, heating up reactants using product heat, but there is some final heat which must be rejected to atmosphere by utility cooling, so that's this U part, right? Separation part we already looked at. I think almost every group had this tank, because we said it will be truck product offtake method, so we need some buffer volume. So based on 1 day, 2 day, 3 day, whatever you consider, that will define volume of this tank, right? Then we put how we want to control the plant. So we want to control so normally in plant, basically you can categorize in 3 different things. One is quality control, one is inventory control, and another one is production control. So flow and those kind of things falls into the production category. Inventory, level control, pressure control, all this falls into this inventory control. So with inventory control, we mean, as we said a few days ago, we want to keep all our reactants, products, whatever our fluids, in the design area. We don't want them to come out of pipes and reactor and whatever. So that's about, so basically three major type of controls. And quality is simply what product you have produced. It's up to the standard of quality specification. I think your group also thought about have a product purification.
Yes, sir.
So based on this reaction, you don't see I didn't expect, but in reality, yes, there is a methanol purification step as well. Because feedstock is something else, there are so many impurities coming in. Sometimes your catalyst is catalyzing this reaction, but there are some side reactions as well. So some byproducts, side products are produced, which needs to be removed as well, right? So after the process control loops on all the systems we see, we can also have a pressure safety valve. So here you could see one common safety valve is downstream of compressor, because compressor is something you put in a lot of energy. Think about suddenly somewhere here the valve is closed, or this valve is closed, your compressor is running. That means your energy input is still happening, still continuously happening, and somewhere this energy will go out. So pressure will keep on increasing. So there are many systems. So, but safety valve is almost every time downstream of compressor to protect it. Then we had the steam drum where you generally have water going to the jacket. Water and steam mixture is coming back in this drum. Water stays as liquid phase, steam is generated and exported, and they also need to protect it properly. Right? Yes, in summary, that's how it's not much different than what you guys have prepared. Thank you very much for the efforts.
So I have
Yes.
one doubt, like
Yes.
in this P&ID diagram, just we have included makeup, BFW and blow down to wastewater treatment from steam drum. So can you please elaborate?
Sure. Unfortunately, it's not very visible here. But what happens is that you want to have very clean water going to your jacket or your soil. So there are so many chemicals what you add in your boiler field water or steam system, right? And you could imagine you keep on adding something. It's once again the equation that Kanti showed, input minus output, generation consumption is equal to accumulation. So you keep putting in these chemicals, you are not taking out anything because it's a closed system, right? So because in steam, there won't be anything. Steam will be pure water. You cannot vaporize these anti-fouling solid things. So they keep accumulating. So what you normally have from steam drum, you simply take out something small stream called purge, and in this stream you have all these chemicals removed. So it's kind of to avoid accumulation of all these chemicals, you need to take out something. So you measure conductivity and other parameters, right? So there is a continuous stream of purge or blow down, but sometimes you monitor your system, if it's going high, so you could do intermittent blow down purging as well. So you simply open the wall, all this dirty stuff, all those solid particles are removed. You want to add something? Yes. Yeah, sure.